This is the Real Digital Transformation podcast series, empowering technology and business professionals to succeed with digital transformation. Now, here's your host, best-selling author Thomas Earl.
Hi, this is Thomas Earl, and welcome to another episode of the Real Digital Transformation podcast. I have with me today Sam Rostam, a senior digital transformation advisor and also part of the Adjunct faculty at the New York Institute of Technology and also a TED speaker. Sam, welcome to the show.
Hello, Thomas. Thank you for inviting me.
So Sam is here today to speak with us about common digital transformation onboarding challenges, drawing from his extensive experience. And so let's open the discussion with that broad topic. Sam, based on what you have seen recently in the world of digital transformation and with more and more organizations adopting digital transformation practices, digital technologies, and moving in that direction, the more recent adoptions and projects that you've seen, what right now are the more common onboarding challenges?
For new enterprises, their challenge primarily is to adopt technologies, solutions that line up with their objectives. And for that, their challenge primarily is to pick and choose technology stack that is easy to adopt. It doesn't have a huge level of investment upfront and is generally speaking cloud-based. And they're ready to experiment and make it work to some level initially. Now, the long-term challenge for new enterprises becomes then all these new solutions that come in, somehow they need to be incorporated together. They need to have an established form of, let's say, customer master across these various tools that they may onboard willingly in a very short period of time. Now, switching to more established enterprises.
Actually, Sam, can I interrupt you? I'd like to just follow up regarding the challenges you just listed for new enterprises. So when you say customer master, are you referring to a data representation of customer profiles across different types of technologies and applications within the enterprise?
Exactly. That's a very nice way to put it. Due to the fact that new enterprises in digital space, they start to adopt multiple forms of ways to communicate with the customer. Digital channels is different forms of communication, and that keeps evolving. A lot of it goes around the mobile industries and how that technology is also, evolving. The issue of consent management, for example, for reaching out to the customer for not just current services, but also potentially offering future services. All of these are something that I call it as customer master that needs to evolve and get managed efficiently over time.
Is it also customer master, customer profile? Is it also ensuring that there's a consistency of the data representation across different systems and applications so that we avoid redundant representations of the same customer information but expressed differently? For example, one representation might have customer name, whereas another might split it into first name and last name and so on. Is it also related to that type of data modeling?
Absolutely. This is a really good example of, I call it data quality challenges. That is not just the actual data being in alignment with the truth, but also the variations of the data representation. The schemas across, different tooling can become not only a headache to later on consolidate these, but also lose touch, having a reliable form of something that is really essential to know about the customer and derive from that further intelligence. So again, garbage data, the decisions that you make based on those or solutions, decision support solutions that you may come up with may not, in fact, not only bring value, but in fact, it could be causing significant issues for the organization down the road for auditability perspective and traceability. So that's data quality element is really a huge element if we don't have that customer master view.
I would assume, Sam, that if you are a new enterprise and you have the benefit of being able to begin with a clean slate, a blank canvas that you can then design, assemble your infrastructure and technology architecture from scratch, and then establish these types of consistent customer profile data representations from the beginning, I would assume that makes the onboarding process easier than if you're an established enterprise with legacy systems that go back years or decades that have all kinds of already existing customer data representations that you then have to federate and add transformation to in order to convert them to some sort of global uniform data representation. I would assume that that's more burdensome and perhaps more risky as well. And I guess that leads us into what you wanted to move on to next, which is onboarding challenges for established enterprises.
Yes, in fact, that's a good segue into that. But just before I move there, you're absolutely right. When you start with a clean state, you really have a lot of good opportunities to establish what is necessary. I may call it system of records, for example. That is important to define and keep it consistent throughout. Again, in any enterprise, regardless of the speed at which you want to move and adjust and be agile, there is element of stability that is required. And over time, in multitude of projects, I've seen that level of stability is really going back to the assets, which is really the data. So if you're starting with a new sort of an enterprise, there is a lot of interest in adopting new solutions, in particular SaaS-based solutions that are cloud, delivered. And a lot of these SaaS-based solutions, they do not, in fact, give you any indication of your need to establish that level of consistency that these tools, in fact, they do not provide, nor they may, in fact, drive you in a different direction, because every single one of these SaaS tools that are easy to onboard, they will have metadata, and in fact, at times they actually have some data in there. So it becomes more of a challenge over time if you don't have that clean state established for data that needs to be more stable, and then you build on it for the things that need to move fast to accommodate new challenge. Now, if I switch back to the established enterprises, again, your point is right on. Enterprises that are established, generally, they have a large footprint, not just in terms of data assets, but also in terms of platforms, infrastructure. A lot of those are diversified across, implementations and technology stacks. Even presumably, some of those are still mainframe based, believe it or not. So they have, in fact, even for established enterprises, really there are two sides to it in terms of challenges. One side of it is about the data. Normally, established enterprises have massive amount of data that have accumulated over time, and sometimes this data is not a right fit for the consumption of this kind of new workload that we want them to be, delivered through various channels. So, for example, those data that are accumulated over time, a lot of it are core data. They may even have relationship data mixed with it. So that brings a lot of difficulties over time, because with new channels, you need to establish new relationship data, and presumably that relationship data does not belong to that core data set. So that massive data set that you have, you really need to refactor that and keep your core data separate from the relationship data so that you can establish new relationship data for the new channels that you're delivering. So that's really one aspect of it, which is the data part. Even they have massive data to use, they need to accommodate that for the new use cases. So the refactoring part becomes necessary. I've seen that across the board in public sector and in private sector.
And moving away from the data for a moment, Sam, and looking at more moving away from the data modeling, I guess, and looking at more the necessity to introduce data science technology systems that don't just work with data or use the data that we've modeled as input, but also produce brand new data intelligence for us to assist with decision making and giving us true insights as to where we should go, what we should do as business decision makers, and perhaps even assisting automated decision making, introducing that technology set into an existing or into a new enterprise architecture that would normally have been built around distributed applications. And, with an existing enterprise, we'll have channels into legacy repositories and systems. Bringing that whole aspect of data science, technology processing into that picture, how have you seen organizations tackle that, both from a technology level perspective as well as a skill set perspective? Because it introduces the need to understand data to a much deeper extent than developers and architects may have had to in the past. It brings in the whole aspect of analysis and analytics and brings that whole level of understanding that's required. And again, it also brings in the risks that come with not understanding the systems and the data techniques that come with it sufficiently, and thereby producing flawed data intelligence. That whole dimension to enterprise architecture, to the enterprise ecosystem that we're building, how have you seen organizations react to that new responsibility?
That's a really, really important question, Thomas. And I can try to see it from different perspectives. You pointed the data science projects. I see data science as, of course, it's a new data discipline for, coming up with machine learning, deep learning, perhaps moving to AI. However, the steps that is required to start with the core data or the data that corporations, in fact, might just also rely on in terms of ingestion or ingested data from other sources, it takes a number of iterations, engineering processes to actually bring it to the level where the data scientists can work with algorithms for machine learning, deep learning, AI. Now, so those steps that are required, I call it part of the methodology that needs to be applied. To me, is an engineering practice that needs to be in place to bring that data in various pipelines. You pointed out about the technology that is used. A lot of organizations that they have massive data, they use Hadoop-like infrastructure or various implementations of it, for example, MapR. And these technologies, in fact, are tailored towards a pipeline approach or methodology where the data moves from one stage to the other towards consumption by the data scientist. So that brings the importance of this methodology to be as an engineering practice. Software development lifecycle applies to that. There is some coding done in various languages, use of queries to the Hadoop-like big data, Spark, for example. And in terms of the skill set, that's a huge element of it for two reasons. Number one, a lot of these tools are like even Hadoop based. They support query languages that are similar to SQL that a lot of developers have been used over time, and it's very established way of accessing data or going through the data set. What I've found in reality is that in order to really process the data or even inspect it properly for the discovery phase of it, the assumptions about how the SQL works usually doesn't apply. So really, organizations need to bring the data engineers that, in fact, their activities feed into the data science to the point where they can, in fact, use these tools effectively. So in short, traditional SQL-based way to see the data, despite the tools supported, is not scalable. And you will see issues with, you may call it the capacity issues or data size issues. But again, we're talking about big data. That's expected. So using the right tool, using the right method to access the data, and making sure that the data engineers and data scientists, that they work together in prepping the data towards running algorithms, creating the value, they actually can process the data. And of course, when they're processing the data, they modify it along the way through the pipelines. The data quality aspect gets a primary focus.
Mm-hmm.
And that's really the part that needs to come together. So in short, the skill set needs to really be tailored towards what the big data infrastructure is relying on, and the traditional methods with data access doesn't really work. And secondly, the entire practice, especially in regards to the use of technologies that are more advanced, MapR, technologies that are based on Hadoop and distributed file system, really needs to be looked at in terms of an engineering practice.
And the
And
skill sets need to extend into data quality assurance as well.
absolutely. In fact, that doesn't have to address the data quality on the spot, but data quality, in fact, is another item that I was going to, talk separately. That's really, really important. The lineage that is required, because you're having pipelines in these frameworks like Hadoop to start from the, presumably ingestions from the source systems, could be IoT systems, could be streaming, QA, quality, the data that comes in from a variety of sources, a variety of data, and these go through stages to arrive to the point where you can actually do data science too.
Mm-hmm.
So the lineage across this is super important, and a lot of times you have to rely on tools to deliver that lineage for you with the proper configurations and so on. So that's, again, something that is important to take into account.
Moving beyond that now, thinking of other digital technologies that are commonly required or that we need to plan for as part of an onboarding process, what other challenges have you seen?
I think the other challenge is the cloud. The cloud onboarding and the cloud usage of tools and techniques is almost, a common assumption for this kind of workload.
Sam, for those organizations that are established and are already cloud proficient, have incorporated cloud computing into their enterprise architecture, are already using it for some of their repositories or distributed systems, are there any onboarding challenges that come with digital transformation that further impact or relate to how cloud computing needs to be incorporated, extended, or further evolved as part of their IT enterprise? Like, for example, hybrid clouds, multi-cloud. Are there new considerations that are introduced when undergoing a digital transformation initiative?
That's a really good question. In fact, when we talk about cloud, let's say public cloud by and large, in fact, the level of adoption across enterprises varies. I've even seen organizations where they consider themselves very much in the midst of the journey to the cloud and they have adopted cloud. When you look closer, you will see that their adoption is limited to primarily SaaS-based products. These are low risk, highly agile projects that you could take on and adopt SaaS products, even productivity tools that are cloud based. Personally, I find if their organization is only looking into, or they have established cloud capabilities that are SaaS based, I still think that their journey within the cloud is just the beginning. For example, when you start using the cloud for platforms such as Databricks, that is for, let's say, big data analytics, and you don't want to host all of that on premise. So basically, you're looking into a PaaS on a cloud. And when you start looking at a cloud vendor, for example, Azure, to use Databricks, then you will see that on an Azure platform, you have choices of Databricks, native Databricks, or the Databricks that ties into Azure native services. So again, now at this point of the game, you will have now two choices. Now, moving from SaaS to PaaS, still it takes a different level of involvement for organization, because then now based on the shared responsibility model, this is not easy as SaaS. The level of involvement is more. And now when you're looking into a PaaS product that goes and connects to native services, you're essentially adopting infrastructure as a service on a cloud environment. This is a totally different ballgame for a cloud workload that the organization is onboarding with.
So what you've seen is that because of the necessity to bring cloud computing into the IT enterprise to a greater extent, there is correspondingly a necessity to move toward platform as a service or even infrastructure as a service environments, because there is so much more that we'll need to implement and manage in the cloud. And that necessity is driven by the digital transformation initiative itself. It just sort of propels us in that direction. If previously we had been primarily using cloud for SaaS implementations, undergoing a digital transformation will likely push us toward taking on greater environments, greater responsibilities, and putting more data and assets in a cloud environment, which results in the need to begin working with PaaS and infrastructure as a service type of environments. Is that correct?
Yeah, I couldn't have said it better, Thomas. This is really the point of the matter. With, as you know, with SaaS products, the level of responsibility is literally minimal from the organizational perspective. You almost have a babysitter that is responsible to, manage the accounts for the SaaS, and they don't primarily host any data. But when you're looking into moving to PaaS, like Databricks platform, that is very common for data science and data engineering type of workload based on Hadoop file system and the MapR or Databricks is a good example of that. You're looking into, in fact, hosting your data. That's one thing that has, of course, security and compliancy and sort of dependencies on. And the other part of that is, in order to really leverage these PaaS platforms, which now you have more responsibility from organizational perspective that you need to govern, but also a lot of those connect you to the IaaS. In fact, you cannot stay away from infrastructure as a service because now you're hosting your data at a minimum and you need to allocate the storage mechanisms, various storage platforms. Even if they're partially supported as a service, it still is infrastructure that you're getting yourself into. So the new issues, new problems come to the surface now. How about the data on the cloud? Do we have to anonymize the data? And some of this data, if you anonymize the data, may lose value from the perspective of AI perspective. So there is a new set of issues and problems that need to be looked at, in addition to the fact that you are pinning yourself down to a cloud vendor. So you're no longer portable. That's another side effect of this, moving from SaaS to PaaS and IaaS. You better have a plan and a strategy around what I call it as a primary cloud vendor or primary cloud provider, because up to this point, you are definitely multi-cloud already, and it doesn't hurt the business. But now you need to start look very carefully to centralize on a primary cloud vendor where your PaaS workload and your IaaS workload is targeted to one environment, because you have a lot more to take on, and you have to also have some skill set. Again, goes to the question of the skill set we talked earlier, that you cannot really build up skill set across multiple cloud vendors, especially when it comes to automations that are required. So you will spread yourself thin on that.
Okay, Sam, this was very insightful. Greatly appreciate you sharing your experience with us.
It's been a pleasure, Thomas, to be part of your podcast series.
Thank you, Sam. Thank you for joining us, and look forward to speaking with you again soon. Take care.
Thank you.
Thank you for listening. Follow Thomas on LinkedIn